So as we discuss Saturn then, after discussing Jupiter, there isn't a whole lot to say about Saturn because it's very similar, the planet itself, very similar to Jupiter in composition. It's a little bit smaller, nothing too interesting to say there. But one thing that Saturn is very unique about is, of course, it is the ring planet. So I'd like to just tell you a little bit about why Saturn has rings, we think. Of course, you must always start with getting some just beautiful views of Saturn. And by the way, all of these are actual photographs of Saturn. I believe it was the Cassini space probe, if you ever want to look it up. Has done some flybys. These are all actual photographs. Here's a size comparison with Earth. So see, once again, it's an absolutely huge planet. That isn't where the Earth would be relative to this view. It's just a direct size comparison. And you can clearly see the shadow of the sun. Yes, this is a real photograph here, and you can tell by looking at this photograph here that, of course, the sun is over here. Big shadow cast in the back. Can't see the rings, but you can see the rings there in front of it. And even here, you can see a shadow of the ring on the planet itself. And this is also an actual picture. This little blue dot right here is the Earth as seen from Saturn. And there's been a lot of philosophy about this, like of all the things that ever existed in history and things people have done and all the wars and famine and wealth and whatever we have, it's all right here. That's it, all on this little so-called pale blue dot. Everything we've ever known or will know is on this one little blue dot. That was a view as Cassini was moving away from Saturn, so you can see that the sun would definitely be over in this direction here. We're looking at the back cast shadow. This is a picture that I happily took from my backyard in my telescope. Quite fun to work on this with a telescope and see a little white dot look like that. But then suddenly when you get some little bit of magnification and some focus, the structure of the ring starts to come out. Very fun to do. And so I just don't have much to say about Saturn. It's very similar to Jupiter in size and composition. All the things that we might have said about Jupiter, including the helium and the hydrogen, all holds for Saturn. They're very similar planets. And the planet, one of the moons of Saturn, Enceladus here, is definitely very similar to Europa also. It's the same sort of thing. It has the ice, has the water, has the minerals, and it has the heat. So it's another one of these candidates to go explore looking for life, but same challenges, big thick ice, one would have to drill down and so on and so forth. But let me just tell you then, like, why Saturn has the rings then. Why would that happen? Well, one thing that I won't discuss that's definitely plausible, it was just leftover material from the nebular hypothesis idea here. That there's all this swirling rocks and things that just sort of never made it into the planet and never coalesced into a moon or whatever. So it just sits there orbiting Saturn. This is definitely one plausible explanation for it. But the other one is as follows here. As we've discussed a few times now in relation to the moon and poor Io here, you get this tidal bulging here that's caused by the gravity of a planet on its moon. And so if here's a planet like this here, and you have a moon here, the moon would like to stay nice and round, but of course it doesn't do that because of these tidal effects with gravity. Is that actually what the moon's going to look like? It's going to be something more like this. It's going to bulge towards the planet for the reasons that we've discussed a few times now. You can always sort of divide the planet in half. The gravitational pull on this side is stronger than it is on this side, and so the planet bulges like that. So the question then is, when you get the bulging here, is can the moon break? I mean, as long as you're actually stretching it with gravity and it's bulging like this, is there a point where it can break? And the answer to that question is yes, it can. In fact, it's very well sort of known by not so difficult mathematics that we won't bother to go around, but if you sort of put the moon at a distance here of 1.26 times the radius of the planet, then it will break. It will break. So what does this mean? It means, well, you have a planet like this, and if the radius of the planet sort of is a number like this here, so here's the planet, and maybe this is r sub p, the radius of the planet. If you go out to 26% longer than that, so maybe like a level right here, or this number right here is 1.26 times the radius of the planet. So just go out 20%, 26% longer than the planet. This is where things made out of rock, say, will break. So if you get out here where most moons and things are, you'll warp, but inside here you'll break. So this is sort of like the zone where you'll just sort of warp due to the tidal forces. But if you get inside this region, you'll break. Okay? So more concluding results on this in the next video.